Hello, check, mic check. Hello, check, mic check. Okay, so today we will start solving graph problems, and yeah, we'll solve first from cses, and after that we will find more graph problems. I don't think AdCoder has a graph problem. Okay, so we'll see. We'll see. But first we'll solve all the cses problems, and also one problem in DP section of cses is still not solved. So, and in the AdCoder DP section we have like four problems, I think, which are not solved. These okay, 5 problems, so we'll solve these later, because I feel like I should learn about the concepts used here, because I'm not able to think in any direction right now. Even if I go there and like maybe for grid I can do something, but yeah, I'm getting bored of solving DP problems. So we'll add graph in the mix, and then I think it will be not as boring, for me at least. Okay, so where do we start the graph? Should we make a new? I think we should make a new this. Okay, so how do we create new? So this is graph. Okay, so we have a lot of problems in graph, maybe more than DP. Yes, like almost double. So the first question is, you are given a map of a building and your task is to count the number of its rooms, the size of the number of centers and squares, and each square is either floor or wall. You can walk left, right, up and down through the floor squares. The first input line has two integers and the height and width of the map. Then there are n lines defined characters dot or hash. Print one integer the number of rooms. Print in one integer the number of rooms. The number of rooms. I mean, it is very simple actually. Where is graph? So is this zoom size correct? Maybe this is correct. Okay. Counting rooms. Counting rooms. So we have this input. Okay, and the rooms are basically, I think the input is not proper. Okay. Now it is. For this as well. Okay. So the room is basically the floors which are covered by wall, right? So if the answer is 3 here, that means if this is the floor, then these are walls. So whatever is surrounding it, if it is completely surrounding it, then it is a room basically. So all the dots that are connected and within this, okay, that is basically our answer. The number of those such dots, not dots but collection of dots. So if you have a, there is a problem in lead code, the orange island, no, the island problem. Yes, it is basically similar to that. So we'll start the DFS or BFS. We'll do DFS from the room, the floor, and whatever dots it reaches, that is included in the room. Okay, in that room. And similarly, we'll do it for all the dots, and check before doing a DFS if it is already visited. If it is, that means it is already included in a room, so we will not proceed. So logic is very simple. Do I have to write it? Don't think. Okay, let me write it. Connected components. Number of not connected components. Number of components. This is our answer. This is our answer, where dot represents our floor and this represents wall. Number of components of this. Okay, so let's solve this problem. We have this. Should I go for a global NNM? I think it will be more beneficial for future problems as well. So this, and we'll take the input. It's a string, na? This is a string, so vector of string. Let's see, map. Graph. Okay, or let's say map. And for 0, and we will take input. Before that we'll have a size, and we'll take input in map, and then we will have an answer. We will have answer, and we will also have a boolean array with initialized with, let's say, not boolean array but 2D array, boolean 2D array. Size will be n and m only, and initially it will all be false. Okay, so for start from 1 and go till n and check for if it is not visited, then we'll do the DFS with this. Also we'll increment the answer. At the end we'll print the answer. Now for the DFS, void DFS, so this thing should be here. Now I'll do mp dot resize, and okay, so we have a source. We also need this to be there, or we'll pass it. Yes, vector pb %vis. So we'll do this, and for all the we can go in 4 directions, right? So for I going from -1 to 1, and again I j going from -1 to 1, if I plus j, the summation of them, the absolute sum of them is equal to 1, because for the 4 directions we would want to go from here, we would want to go here. So if it is 0 0, if it is 0 from here, we have 4 directions. So if it is 0 0, then this will be 1 0, this will be -1 0, this will be 0 1, and this will be 0 -1. Okay, so the sum of the coordinates, absolute sum of the coordinates, is 1 only. We'll do DFS again with oh, okay, I cannot do this, I need to do this. And it will be I, it will be j, and let's say x, and let's say y. we will go in the direction. I also need to check. If, let me check it in here only, and my I plus x, or rather I'll make a function, boolean is okay. So I'll have two numbers and I'll just return I is less than n and I greater than equal to 0, and j is less than m and j is greater than equal to 0. So I'll use that check function here, okay function, for I plus x and j plus y. Okay. And if it is okay, we'll do DFS for I plus x, j plus y, and of course for this. This should work. Here we'll have to change. We will include another loop going from 0 to m, and inside that we'll put this. Okay. Sure. So Control C, Control V, Control V. Okay. $48. J. If not, where's IJ? There is a segment fault, most likely because we are trying to access this. So the answer is 12. I plus x, j plus y. What is the issue? 0 1 2 3 4 5 6 7. So it is 2 2 or 1 1. I'll do a DFS on 1 1. DFS 1 1 was, and then C. Okay, so it is a problem in DFS only. Okay. I feel like I should. No. So, and new I is equal to I plus X. New J is equal to J plus Y, and I'll change. So NJ NI NJ NI NJ. Okay, the system, let's see what is the state of our Viz array, Viz 2D array, Viz matrix. Viz I J. Okay, it is working. So comment run. Done. So it was an issue from, like, I forgot to include these two things, because of which I was getting segment fault and other issues. Okay, so this should work. Logic is same, nothing is changed, and let's submit it. Okay, what was the last time? Because what did I submit last time? Similar. It is very similar. Okay. Next question. You are given a map of a labyrinth and your task is to find a path from start to end. You can walk left or same. The first input line has two integers, the height of width and map is floor, start or B. There is exactly one A and one B in the input. Print yes if there is a path and no otherwise. If there is a path, print the length of the shortest such path and its description as a string consisting of characters left, right, U and D. Can print any valid solution. So we'll have to do BFS from A. Okay, we'll have to do BFS from A. What is this? Labyrinth. Second problem, labyrinth. So the problem is very similar. Start BFS from A and keep track of path by having a state of direction not count. The length itself will be we can extract the length from the path itself. Okay, so yeah, start from A and start BFS. So from A, our goal is to go from A to B using BFS, and we have to ensure minimum path. So BFS will ensure that it is minimum. Okay. Yes. So yeah, I'll make BFS also. So again, I'll have I'll have J. I will not have a vector this time. I will do it inside BFS. So we have a vector pb ampersand with, or we should pass it here only. Okay, so let me pass this, let me copy it from this, and okay. So we will have a queue, and this queue will have, we need the node, we need the direction of it from its parent, and we also need an array to basically store what is the minimum path from A to B. So we'll hop parent to parent. Okay, to make the string also. Okay, yes. So Okay, so we'll have a vector of 3 size inside the Q and let's take the example. So we okay. Whatever. So we'll start from A. We will BFS it. So out of all the possible, we can only go here. So this will be updated with the state. So here the state updated state will be whatever its position is, comma the length with length to reach here, the path length to reach here, which is what is the path length? Okay, so the path is one only, and then we have the string itself, so it will be L. But since n and m can be as large as 2000, so string will be 20 to the power 6, and string can be that large itself. The string can literally be as large as n into m. So don't think that should be possible. But again, it's an average time, right? So this should work. If it does not, we'll change our keys. So if we encounter a node and see that it has a minimum paths already set, then we will continue out of it. So we will need a buffer as well, buffer to store the minimum path length till that node. And should we also have a Okay. So I, j, and the path length should include the in string answer. Q dot push push and 1. Okay, and we will have dx minus 1 0 1 0. I'll have dy 0 minus 1 0 1. Okay, we have all this. Then I will do this while not q dot empty. We'll pop the first node, so auto st, it's basically q dot front, and you can see that we will have the coordinates of the current state as well as the minimum path leading to it. The yes. You need to run a BFS from here. Q dot pop, we will have the new coordinates, that is A is state dot ff, B is state 1, and the main path is state 2. If we have another array which is distance of size n, sorry, if the distance to reach A and B is less than the current main path, we will continue. Okay, I don't want to add additional states, and after that is done, I will do is AB is true, also if not was A, B. I will also continue. And then the main thing, we have this 0 I and these new indexes are not okay.